Hello, thank you for joining me. My name is Denver, and I am a mechanical engineer from Rensselaer Polytechnic Institute. Today, we will be going over the Global Position System and the way that it functions. GPS has many different applications spanning multiple areas of life. One use of GPS is to track the movements of large aircraft carriers as they sail throughout the seven seas. Also, it is used to track monarch butterflies as they migrate across the Americas. GPS is even used to create crop mazes for seasonal fun in the fall months. In this presentation, first we are going to talk about what exactly the true definition of GPS is, and the answer may surprise you. Then we will dive into exactly how GPS can locate your exact position on the surface of the Earth using a process called triangulation. And finally, we will talk about a few main sources of error and how to correct for these. Believe it or not, GPS is not the small device you stick on your dashboard when you're going for a drive. This is called your GPS receiver. The GPS itself is a constellation of 27 satellites that orbit the Earth. 24 of these satellites are always active, while the remaining 3 are backup in case any of the main 24 go out of commission or need to be fixed. Looking at this diagram, we can see exactly how the satellites orbit around the Earth. You are the blue point on the Earth, which is represented as this colorful ball. You can see that the dots orbiting the Earth are the GPS satellites. It can be seen that as you, the blue dot, moves around the Earth, there are always at least 4 satellites for which you are visible to. This is represented by the green lines going from the satellites to the blue dots. So what exactly does it mean to be in view of a satellite or visible to one? This takes us to our next topic of triangulation and how exactly satellites work in order to give us our position on Earth. To begin this process, first we need to calculate for the distance between the satellites that are orbiting our Earth and the GPS receiver that we have in our hand or in our car. How this is done is, at a certain point in time, the GPS satellites that are orbiting our Earth will give off a signal which is in the form of radio waves, and it's a long pattern. At the same time, our GPS receivers also start running the same pattern. Such radio waves given off by the satellites take time to travel from space to the GPS receiver on the surface of the Earth. So when they finally reach the receiver, the pattern that is sent out is delayed by a certain amount of time from the pattern being run by the receiver. This time delay corresponds to the time it took for the radio waves to travel from the satellite to the GPS device. We know how fast the waves emitted from the satellite move, and we also know the time it took for them to go from the satellite to the GPS device. As we can see in this equation, speed is in meters per second and time is in seconds. If we multiply the two together, the seconds cancel out and we are only left with meters. Therefore, the number we get out of this equation is the distance from the satellite to the GPS device. By knowing the distance away from a satellite you are, you can determine your position on the Earth. Here in this demonstration, we see the Earth. If we are to have one satellite and send out a message, then we know how far I am from this satellite. I would be somewhere on the circle. Every point on that circle is the same distance away from the satellite. However, we want an exact position, not many places that I could be. This means that we need more satellites. If we had another satellite and sent out a message, we now have another circle of where I could be from it. So now we have 2 circles and I must be present somewhere along both circles. This means that I must be at the intersection of the 2 circles, but there are 2 intersections currently, one on the Earth and another out in space. This means we must add one more satellite to find the exact position. So once again, we send out a signal and find how far I am from that satellite. We now have one single intersection between all the circles, which means I must be present at this point. This process is called triangulation. Now, the previous example was in 2 dimensions, but we live in a 3-dimensional world. That means that we must have actually 4 satellites available in order to track our exact position. Now, we will get into correction for errors in satellites. The Earth's atmosphere varies greatly and has different densities depending on the distance away from the center of the Earth. The densities of these different atmosphere sections actually hinder the speed of the signals from the satellites, which makes it seem as if the signal takes longer to reach you. This means your position would show up further from the satellites than you actually are. Another example of error could be when you are in a city. As the signal from the satellite comes down, rather than going directly to your phone, it bounces off a building to your phone. This would also mean that your phone thinks you are further away from the satellite because the signal traveled further than necessary. In order to solve for all of these different sources of error, there is a system called differential GPS that is used to correct for all of this. There are ground satellites that are present in many different locations around the Earth. They are used to gauge for different factors close to its area that are messing with the data. The ground satellite knows its exact position on the Earth, and the satellites know their exact position as they orbit the Earth. Therefore, they know the exact amount of time it should take for the signal to come down from the orbiting satellite to the ground satellite. If these times do not match, then the ground-based satellite makes some corrections to account for this discrepancy. As you pull out your phone, it receives the signals from the orbiting satellites just as it should. But as your phone starts making corrections to determine your position, a ground satellite close to your location will send your phone the corrections made by it to increase the accuracy of your position. Some of these systems are so advanced they can track your position to within a couple of millimeters. Many different engineers are needed in order to make sure GPS works as well as it does. Mechanical engineers help design different portions of the satellite to make sure it can physically perform the actions needed. Aeronautical engineers help plan the orbit of the satellite around the Earth. Electrical engineers help make sure all of the power requirements of the satellite are met. And finally, software engineers design the code to send out signals from the GPS. It is this constellation of satellites orbiting around the Earth that allow you to know your position. This technique of triangulation is very powerful when combined with the correcting properties of ground-based satellites. With all of these systems working harmoniously, it allows us to track those migrating butterflies, create crop circles, and most importantly, help us catch them all in Pokemon Go. Thank you for watching, and I hope you enjoyed watching this Reach presentation. Hello, this is Denver again. Thanks for tuning in to see the hands-on portion of the GPS presentation. So with our newfound knowledge of triangulation, we are going to solve a murder. So the materials that we need for this hands-on activity is a compass, a ruler, 4 different markers of different color, and these worksheets that you will be seeing here in a second. So this is Two-Door Mansion, and a murder happened in the kitchen. That's where Mr. John body was found, and we need to find out who killed him. The killer is also located in the kitchen. So let's get started. Let's read the complete introduction. Welcome to Two-Door Mansion. Your host, Mr. John Body, has met an untimely end. He's the victim of foul play. To win this game, you must answer the following question. Who else was in the kitchen where Mr. Body took his last breath? The following suspects have given us their locations at the time of the murder, but mysteriously they are all in terms of the other rooms. Someone's hiding something. Your job, with your newly acquired knowledge of triangulation, is to find out where each of the suspects were when Mr. Body died. And with that, let's get started. So, Colonel Mustard, at the time of the murder, was 2.5 inches away from the billiard room. So what we're going to do with that information is we take our compass, if I can open it, there we go, and we have our ruler here, just like this, and we measure the compass out to 2.5 inches away, which is the distance given in the worksheet. And he was 2.5 inches away from the billiard room. The billiard room is right here, so we put the pointy end of the compass right on the name of the billiard room, and then we draw a circle, like so. And we can see that the legs spread out a little bit, but that's okay. We don't need to be exact. So we're going to label each person with a different color. Colonel Mustard is going to be yellow. Ms. Peacock is going to be pink. And Professor Plum is going to be purple. And Mrs. Scarlet is going to be orange. So now that we've drawn our first circle, we're going to outline that in yellow so we don't forget whose circle this belonged to. And as we can see here from this circle, it looks like there's possibly 4 different locations that Colonel Mustard could be in right now. The study, the hall, the ballroom, and the conservatory. So we need to add some more circles in order to figure out his exact location. So if we figure out the other information, he was 4 inches away from the lounge. So again, we take our ruler and we measure out our compass to 4 inches, like so. And he was 4 inches away from the lounge, and the lounge is right here. So again, put the pointy in there and draw a nice circle, like that. And then we color this in again with yellow. and it looks like we have 2 intersection points. So it looks like that he could be in the study or the ballroom. So we need one more circle in order to figure out his exact location. And the last piece of information is he was 2.5 inches away from the conservatory. So we take our compass and measure it out to 2.5 inches again. He was 2.5 inches away from the conservatory, so pointy end here, draw our circle. And it looks like we have an intersection in the ballroom. So it looks like that Colonel Mustard is in the ballroom the whole time, which means he couldn't be the murderer because the murderer is located in the kitchen. So we'll go back to our worksheet here, and we'll say Colonel Mustard was in the ballroom. Now we can go on to Mrs. Peacock. As Mr. Body was brutally murdered, Miss Peacock was 4.5 inches away from the library. Get our ruler again. Take our compass. 4.5 inches away from the library. The library is located right here. Pointy end. Draw our circle. Like so. Then let's go over that in pink. And it looks like we have 4 possible locations. The ballroom, the kitchen, which is where the murder happened, the dining room, and the lounge. So again, let's continue drawing some more circles. The next piece of information is she was 4.5 inches away from the ballroom. We already just measured our compass out to 4.5 inches, so we don't need to do that again. And she was 4.5 inches away from the ballroom, which is right here. So something important to note is that I didn't draw this circle all the way across and I didn't draw this circle all the way across. So when I outline this, it's going to look like we only have one intersection, which means that we should be able to stop and say, okay, we know where she is. But there technically is still an intersection somewhere over here between those 2 circles. So we should still draw one more circle even though we only have an intersection on the map. We're just trying to be absolutely sure that we know where she is. So we will draw a 3rd circle. And the next piece of information is she's 2 inches from the hall. So again, we measure our compass out to 2 inches, like that. The hall is right here. Whoops. And here's our next circle. And like I said, there's an intersection at the lounge. So again, Miss Peacock couldn't have been the murderer because she was located in the lounge. Now to Professor Plum. And Professor Plum was 4.5 inches away from the conservatory. So ruler, 4.5 inches from the conservatory, right here. Again, it looks like we have 4 possible locations: the study, the hall, the dining room, and the kitchen. Oh man, it means he could possibly be the murderer. So now the next piece of information is he was 2 inches away from the dining room. So 2 inches right here from the dining room, which is located right here. Draw our circle. Oh man, we're dialing in on his location. Looks like he could possibly be in the hall or the kitchen. The final circle will tell us if he was indeed the murderer or not. The last piece of information is 5 inches from the hall. So we measure that out to 5 inches right here. 5 inches from the hall. So we draw our circle. Oh, it looks like we have found the murderer. We have an intersection at the kitchen, which means that he must have been the murderer. Well, it's a good thing that we found out who it is so we can put them behind bars. But the thing is, we're not done yet. We still have one more person. We have Miss Scarlet, and she could possibly be an accomplice. So we need to make sure that she wasn't also located in the kitchen. And the first piece of information for Miss Scarlet is she was 5.25 inches from the conservatory. So measure this out to 5.25 inches, which is right there. And that was from the conservatory. Draw our circle. And again, we have 4 possible locations, which is the study, the hall, the dining room, and the kitchen. So she might be an accomplice. The next piece of information is 3 inches away from the dining room. So we measure out 3.5 inches. 3.5 inches. Oh, actually 3 inches from the dining room, sorry. 3 inches. Here's the dining room. Oh man, if I was to have extended this line, we would have had another intersection here. So it looks like she could either be located in the kitchen or in the hall. So it's coming closer. It might look like she indeed is accomplice. But let's see. We have one more piece of information. She was 2 3/4 inches from the library, which is right here. And the library is located right here. So let's see. This might be the piece of information that absolves her. And indeed it is. It looks like the intersection is actually at the hall, which means that she wasn't in the kitchen, which means she wasn't an accomplice and she didn't help with the murder. So now we have found every location of every single person. We have Professor Plum. Oh, I forgot to put in the location. So Professor Plum was in the kitchen. He was the murderer. And Miss Scarlett was located in the hall. So it looks like we finally found everybody. And it means we can get Colonel Mustard, Miss Peacock, and Miss Scarlett in to testify against Professor Plum in court to get him behind bars. So great job, everybody. We did fantastically with our new knowledge of triangulation to finally solve this murder. Then I'd like to thank you again. This is Denver Overend, and thank you for watching this Reach presentation, and I hope you have a great day. Thank you very much.